Dear students, today we discuss about Class B push-pull amplifier. We know well that what is Class B amplifier? The amplifier is the electrical and electronic circuit which amplifies the input signal and gives the amplified form in its output. The Class B type, it allows only half of the input waveform in its output. It depends upon the characteristics of the transistor used to construct the Class B amplifier. Here the Class B amplifier has some disadvantages that it produces unwanted distortion noise. To eliminate the noise and the distortion, the Class B amplifier is modified into Class B push-pull amplifier. A Class B push-pull amplifier is nothing but a Class B type amplifier. Its configuration is modified in Class B amplifier to remove the high noises, distortions in Class B power amplifier. Let us see the construction of Class B push-pull amplifier. It consists of two transistors. It consists of two transistors T1 and T2. T1 is the NPN transistor, T2 is the PNP transistor. We know well that there are two types of transistor, NPN and PNP. The transistor consists of three terminals: emitter, base, and collector. The bases of the both transistors T1 and T2 are connected to, it is a base of the second transistor T2. It is the base of the first transistor T1. The both are connected to secondary of the center of the input transformer. This is the transformer. What is transformer? It is an electrical device. It consists of two coils, the primary coil and secondary coil. The coils are wound on the core, metallic core. So it depends upon this, the core type, and depends upon the input and output waveform. It is classified into step down transformer and step up transformer and the impedance matching transformer. Here, the number of turns in the primary coil is equal to number of turns in the secondary coil. So this transformer transforms all the input at the primary to the secondary. The step down transformer is the primary coil turns are high when compared to secondary coil turns. So here the base of the two transistors T2 and T2 are connected to secondary. This is secondary of the center tapped input transformer. So the emitters are shorted. See here, this is the emitters. Emitter of the transistor T1, emitter of the transistor T2 are shorted. They are connected with a wire. And collectors, here, collector of the transistor T1, it is a collector of the transistor T2. The both are given the power supply plus VCC here. The plus VCC is connected to primary of another transformer TR2. The primary is connected to the collector of transistor T1 and collector of transistor T2. The secondary coil is connected to the loudspeaker. So the output appears here. It is a construction of the push-pull class B type amplifier. So the input is given to the input transformer. The output is taken in the output transformer TR2. The circuit operation of class B amplifier is given below. When no current, no signal is applied at the input, so the input voltage is 0, then the base of the transistor T1 and base of the transistor T2 gets 0 voltage. So both the transistors are in cutoff condition. So they are in cutoff condition. There is no collector output. There is no collector current flow in both transistor T1 and transistor T2. As no current is drawn from the source, the VCC, so the no power is wasted. And then when a signal, when the input signal, AC signal, it is a positive off, it is a negative off cycle. It is the input signal, it is a positive off cycle, it is the negative off cycle. They are given to the primary of the first transformer TR1. This transformer splits this signal into two parts, two signals. One is a positive off cycle and negative off cycle. They are 180-degree out of phase with each other, the positive off cycle and the negative off cycle. These two signals are given to the transistor T1 and transistor T2. For the positive off cycle, the positive off cycle given to the base of the transistor T1. The base of the transistor T1 becomes positive, so it is forward biased. As it is a NPN transistor, the base is always be given forward bias. It is a P-type material. A positive voltage is given here, so the transistor is under forward bias, so it starts to conduct. So the positive, the collector current flows in the collector of transistor T1. At the same time, the transistor T2 has a negative off cycle. So the negative potential is given to the base of the transistor T2. So it is a PNP transistor. The base is N-type material. Here a negative voltage is given here. So at the first half cycle, a positive is given here. The same positive is come to the transistor T2. It is a PNP transistor. The base is made up of N-type material. The given voltage is positive, so it is given under reverse bias. As it is a reverse bias, it is a base is N-type material. A positive first half cycle is given here, so it is a reverse bias. So the transistor T2 is coming under cutoff condition, and this transistor does not conduct. There is no collector current flows in this collector. For the next off cycle, it is a negative cycle. The negative potential is given to the first transistor T1. When the negative off cycle is given here, the transistor T1 is the NPN transistor, base is the P-type material. When the negative voltage is given there, it is coming under reverse bias. So the transistor T1 does not conduct. So there is no collector output here. At the same time, at the negative off cycle, the negative voltage is given to transistor T2. As it is a PNP transistor, the base is made up of N-type material. It is N-type material, so negative potential is given here. So it is forward bias. So the transistor comes under forward condition. So the transistor T2 starts to conduct. As it is conduct, the voltage flows in the collector of transistor T2. Now, after this, the transformer T2, TR2 joins the two currents produced. Already the first current produced by the transistor T1 and then the current produced by the transistor T2. That is the voltage produced by the T1 and T2 are combined here, and the two currents are producing an undistorted output waveform in its output like this. So while the transistor are conducting, initially T1 is conducts and then T2 conducts. So the distortion produced, the mixed present in the input signal is eliminated. So this push-pull class B amplifier gives distortionless output. Next we discuss the voltage gain of the amplifier and the negative feedback given in this amplifier. Generally our aim is to remove the noise. The noise level in the amplifier circuits are reduced or eliminated by giving feedbacks, by using negative feedback or positive feedback. Here, a negative feedback, it is a feedback nothing but a fraction of output is given into the input. The negative feedback is done by injecting a fraction of output in phase opposition to the input signal, the opposite, negative with negative sign. Here, a block diagram of feedback amplifier is given. This block diagram consists of two parts. They are, one is the original amplifier and another one is, this is amplifier, another one is feedback circuit. You know well that the amplifier consists of active element as a transistor and the passive elements resistor, capacitor and etc. So this block is the amplifier with gain A. Gain is nothing but the output divided by the input. The amplitude of the output is divided by the amplitude of the input. It gives the gain A. Another, the feedback circuit. The feedback circuit consists of the passive elements, resistors. Here it is the amplifier with the gain A. The A represents the gain of the amplifier. The gain of the amplifier is nothing but the ratio of the output voltage VO to the input voltage given to this amplifier. Vi is the input voltage given to the amplifier. VO is the output voltage appears in the output of the amplifier. So gain A is equal to VO divided by VI. After generating the output, a part of the output, a feed, a part of the output is taken here, and the feedback network it extracts the feedback voltage VF, a part of the voltage from the output of the amplifier. It is VF feedback voltage is equal to beta, it is the gain, feedback gain, into output voltage. This voltage, it is a feedback voltage. As it is a negative feedback, it is a minus VF. This voltage is subtracted for negative feedback from the signal voltage. Vs is the signal voltage. So, the total net voltage, input voltage applied to the amplifier is Vi is equal to V source minus V feedback. We know that what is Vf? Vf is nothing but beta into V output. So this value is substituted here. We know well that the quantity beta is the feedback gain. This feedback ratio, the feedback is nothing but V feedback divided by V output. Here the V output is acting as a input voltage. Vf is acting as a output voltage. So this feedback ratio is called as a feedback fraction. They consider the negative feedback in this case. The output VO must be equal to the input voltage. Vs minus beta VO multiplied by the gain of the amplifier. That is Vi, that is gain is equal to V output by Vi. So we cross multiply this. So Vi into A is equal to V output. You know the value of Vi. Now substitute the value of Vi here. So you will get this equation. So multiply the A with this AVS minus A beta V output is equal to V output. The output V output components are taken at one side. So AVS is equal to V output into 1 plus A beta. So divide this fraction 1 plus A beta here. So V output by Vs. So V output by Vs is nothing but the gain. So this gain is V output by Vs is equal to A by 1 plus A beta. It is the gain of the feedback amplifier. So we have today discussed number 1, what is class B push-pull amplifier, how it is constructed, how it is working, and what is feedback amplifier, how a negative feedback is given, what are its outputs, etc. Okay, thank you.